Hi. We are going to talk about infrastructure as a code for continuous integration, continuous delivery, and continuous deployment. And this project is being made by us for our course, Agisit. First, we'll talk a little bit about DevOps lifecycle. So, DevOps is a set of software engineering practices and tools that aims at unifying software development and software operation teams. Main characteristics of DevOps is to strongly advocate automation and monitoring at all steps of software construction. DevOps also aims at shorter development cycles, increased deployment frequency, more dependable releases in close alignment with business objectives, enabling them to compete more effectively in the markets. DevOps has some good characteristics that take him as a preference against other methodologies like agile methodologies.
We are now going to talk about the phases that most matter to the work we produced. These are continuous integration and continuous deployment. Speaking of continuous integration, it is the heart of the entire DevOps lifecycle. As you can see, it is centered in the image. It's a software development practice used in an environment where developers are required to commit various commits or changes to the code repository several times a day. Every commit is then built, tested, and then possibly deployed. This allows for early detection of problems if they are present, and it strongly reduces merge errors. Jenkins is a very popular tool used in this phase. Whenever there is a change in the Git repository, Jenkins fetches the updated code and it prepares a build of that code with an executable file and will later on be forwarded to the test server or production server.
So now about continuous delivery and continuous deployment. For continuous delivery, it is an extension of continuous integration, and it automates the process of deploying a new build into production. As for continuous deployment, it is a more advanced version of continuous delivery, because the manual step of approving new releases into production is removed. In continuous deployment model, each build which passes all the checks and balances of the pipeline are automatically deployed into the production environment. So now we can see in this slide, this is kind of our physical topology. As we can see here, we use a local machine, that's our client. We use a GitHub repository. We use Jenkins running on an Amazon EC2 instance. We use Docker Hub, and we have also our Kubernetes cluster running on Google Kubernetes engine. And that basically resumes our used softwares and technologies. So now let's dive into the Kubernetes cluster architecture. As we can see here, we have master nodes and worker nodes. On a Kubernetes cluster, it is a good practice to have more than one master. And we can have as many worker nodes as we want or as we need. So we'll also have services. And the pods. As you can see here, we have the pods will have containers, Docker containers, and these pods have some JavaScript image, and we will assume that it's running a JavaScript server. So when a user sends a request to that JavaScript server, we will have a service, and this service is as an endpoint. And if we have more than one pod running this JavaScript image, the service will redirect the request to the pod that has less workload. So it automatically balances the workloads of the pods. Also, in our implementation context, let's assume Jenkins is deploying a new image for this JavaScript server. So what will happen is Kubernetes will create a new pod, and each pod has its IP. So the new pod will have a new IP, and that's why we are using the service, because the service is like an endpoint that is static, but the pods are always changing, so the IPs always change. And because the service is static, the endpoint for the requests on that JavaScript service will always be the service endpoint. So we don't have to send it directly to an endpoint to an IP address of a pod.
So here we have our project on GCP, Google Cloud Platform. And if we come here to the Kubernetes engine, we can see we don't have a cluster yet. So we will create our cluster. Here we'll choose its name. We'll call it CI/CD cluster. Location type zonal, US. No, we have to Europe West 1. Now we create. So now we have our cluster ready, and since we already authenticated, we already have the JSON key to the project. So now we can SSH to our machine. Now that we have already Terraform init, we can do the Terraform apply or plan first. So Terraform plan. So now we already hit the Terraform plan. So we can see if we are what is gonna be our final configuration. We already know what it is gonna be, and we're happy with it. So we can pass straight to Terraform apply. Now we have already applied Terraform, and as we can see, we had a cluster already, of course. So what Terraform apply did was destroy that cluster that we had. It was a default cluster, and then recreating the same cluster but with our configurations. We actually, as we can see, the cluster size is 3 now. It was 1, and before applying, and the total memory had changed also. If we come here into services, we don't have a service or ingress yet, and we have no workloads whatsoever. So we only have this cluster with three worker nodes and 3 masters.
As part of the CI pipeline, our Jenkins will have various stages. These stages can be, for example, commit, build, test, stage, deploy, as you can see in the picture. Basically, when a developer pushes its code, this code will enter this pipeline and do these exact stages. So, for example, in a build stage, the image would be built, or the application or software would be built, compiled, and then tested in the next stage. And in the following, if all went well in the previous stages, the app would be deployed or staged. And that's how Jenkins works. It works through the use of plugins. In our application, as we will show later on in the video, we have used some of these plugins to connect to the various sources that we need in order to integrate a continuous deployment pipeline. Okay, now now what you can see in your screen is a presentation of the description of how our pipeline works for continuous integration and continuous deployment. A developer will start by submitting his code with git push. If it's in a main branch, this code will be immediately built and tested. If not, there will be a new branch in Jenkins. Through the use of a webhook, GitHub will notify Jenkins that new code has been pushed. Jenkins will then fetch this code and feed it into the pipeline. Then this code will go through various stages. In our example, as you will see, we have 5 different stages, but there could be less or even more. We will then connect to Docker Hub to publish our Docker image that was built in the start of the pipeline. And at the end of the pipeline, we will also deploy our application to a Kubernetes cluster running on Google Kubernetes Engine. And now we are going to show to you the demonstration of our work. Now I'm going to show you our use case scenario. So in our use case, a developer will have an application. In this case, it's a Node.js application, as you can see from the file structure. It's a Node.js application. It will have a Docker file defining how the image will be built. So from Node, that's a Node image. And then it will npm install and npm start exposing port 8080. That's default TCP. We are going to write example deployed application. We're going to save that. Also in here, there will be a Jenkins file. This Jenkins file will define how the pipeline is. So the different stages, build image, checkout, deploy to Docker, deploy to Kubernetes, and then create the services in Kubernetes. So right now we are going to push the code we just edited. So we are going to do that. We are using Git desktop just for ease. And we will be able, as soon as we push it, to see in real time the pipeline working here in Jenkins. In this case, we are using the Blue Ocean plugin that just makes the Kubernetes pipeline prettier. Right now, we have build executing. If we click it, we can see the different stages and how quickly it actually runs. So we are building an image right now, and these steps were really fast. Yeah, and now we are going to take care of the deployment to Kubernetes to our cluster we created in the previous. So as you can clearly see, all our pipeline went all right. So we will now check in the cluster if the changes have actually been made. We will firstly start off by checking these changes in through CMD. So we are going to do sudo kubectl get pods, and now we can see our Docker web app that's running. And so we can also check if the services have been created, and as you can see here, it is our service, Docker web app service. We can also check in the Google Cloud Platform. We can check there is a Docker web app running, and if we see the services, there is also a Docker web app service. So if you remember correctly, if we go in this link, we should have an example deployed application. Okay, let's say the application is already up, but the developer does a little change either way. So example, changed application. We are going to commit that, push to origin, and we are now going to watch the pipeline, and it should be running any minute now. And instead of running and destroying the previous pod in the cluster, this will replace its previous image with the new one. So we are just going to see our pipeline working. So as you can see, our Kubernetes pipeline is finished, and we now will be able to see what changes happened in our cluster. So if we just go here to the same service we were at, we just F5 to refresh the page, and we have our change application. So like that, with the touch of a button, literally the developer can have a running application in no time with services and everything there's to go with it. And thus concludes our CI/CD implementation of a pipeline through the use of Jenkins, GitHub, which connects to the CI through the use of webhooks, the CI being Jenkins, of course, using the registry in Docker Hub, and using GitHub as our source code management, and the Kubernetes as our cluster to deploy our applications on. And that is all.